Get ready to meet one of top leaders in robotics. Introducing Venki Ayalur, founder, president, and CTO at Blended, a market-defining company offering autonomous robotic kiosks that use AI and machine vision to prepare fresh, healthy, customizable smoothies accessible 24/7. With a wealth of experience in building innovative technologies and products, Venki is passionate about transforming how we prepare and serve food. Venki is bringing a new era of food preparation and service to our lives. Join us on May 9th at 10 a.m. Pacific Standard Time for Builder Nation's first panel, where we'll explore the role of AI in the future of robotics. Get ready to connect with a cutting-edge thinker in the world of technology. Introducing Dr. Denis Garagic, CTO at Sarcos, the next-generation robotics company redefining human potential with advanced mobile systems and powered exoskeletons. Their teleoperated dexterous robot blends human expertise and robotic prowess, offering an innovative solution for hazardous tasks. With over 25 years of experience in AI and machine learning technology, Dr. Garagic has spearheaded the development of innovative control strategies, intelligent algorithms, and machine learning in robotics solutions. Join us on May 9th at 10 a.m. Pacific Standard Time for Builder Nation's first panel, where we'll explore the role of AI in the future of robotics. Get ready to engage with one of the visionary leaders of the tech industry. Introducing Brandon Robinson, co-founder and CEO of Horizon Aircraft, a forward-thinking aerospace company revolutionizing the industry with their innovative hybrid electric vertical takeoff and landing aircraft. With a wide-ranging background as a Royal Canadian Air Force pilot and expertise in managing large capital projects, Brandon has deep operational experience alongside a profound passion for technical innovation. Join us on May 9th at 10 a.m. Pacific Standard Time for Builder Nation's first panel, where we'll explore the role of AI in the future of robotics. This panel is brought to you by Control Hub, the purchasing software for hardware companies. When building the future is your priority, tedious procurement processes should be last on your list. The problem is that purchasing data is scattered across spreadsheets, receipts, emails, and messages. Tracking it all sucks and makes it easy to commit mistakes. Introducing the Control Hub Way, the all-in-one purchasing software for hardware companies. Buying parts, services, or office supplies? Submit a quick purchase request to buy from your list of approved vendors, or buy from a new provider. Buying from approved vendors is even easier. Import your shopping cart directly into your purchase request using our checkout integrations. When the order is ready, submit it for approval. We'll ping all pre-designated approvers both via Control Hub's website, email, and Slack notifications for a faster turnaround. If you need a PO, we got you. Generate it in one click. Online purchase? Boom, virtual card. Do an automatic three-way match, pay invoices, and sync everything live with QuickBooks or NetSuite. Purchasing just got a lot easier. Control Hub. Get back to building.
Hey there, guys, and welcome to Builder Nation's first panel discussion on the role of AI in the future of robotics, where we'll explore the design and development of robots, as well as the impact of AI on productivity and economic growth. So whether you're a seasoned robotics professional or a newcomer to the field, this discussion is sure to be thought-provoking. Please allow me to introduce our exciting lineup of experts that will join us today. First of all, we have Brandon Robinson, co-founder and CEO of Horizon Aircraft, then Denis Garagic, CTO at Sarcos Robotics, and last but not least, we have Venki Ayalur, founder, president, and CTO at Blend. So why don't we start by allowing our main guests to introduce themselves and give us some background. Venki, could you go first, please?
Thanks, Alyssa, for the nice introduction. I'm Venki Ayalur, co-founder and CTO of Blended. At Blended, we build fully autonomous robotic kiosks that make smoothies, right? It's powered by machine vision, AI, and robotics, all the good stuff. It's a first of this kind where it makes a fully healthy smoothies end-to-end, completely autonomous. And we've been on several locations and we are growing as we speak.
Amazing. Thank you for that amazing introduction. Denis, can you share?
Denis Garagic, I'm a CTO and head of engineering for Sarcos Robotics and Technology Corporation. We are based in Salt Lake City, Utah, and Pittsburgh, Pennsylvania. Sarcos is a leader in dexterous mobile robotics, especially in unstructured environments. We build a variety of robotics platforms, including exoskeleton, including humanoids, including underwater vehicles, dexterous arms. So kind of full portfolio of climatically different robotic systems. We apply autonomy in most cases, but also we use teleoperation to enable human-robot interaction, especially in unstructured environments, which are continuously changing, and outdoor environments, which is a little bit different than what traditional industrial robotics applications are done. So a lot of development in terms of hardware, but also software, intelligent software, including AI and controls, perception. So it's kind of full suite of this kind of solutions.
Great. Thank you for sharing that as well. And last but not least, Brandon, please go ahead.
Lisa, thank you. So Brandon Robinson is CEO and co-founder of Horizon Aircraft. We're a small OEM based out of Ontario, Canada, building an electric vertical takeoff and landing aircraft. So think of an aircraft that can take off and land like a helicopter, but travel about twice as fast and is cheaper to own and operate, and much more sustainable as well. So before I did that, I was an Air Force fighter pilot for the better part of 20 years, did the Canadian version of Top Gun, have a mechanical engineering degree and an advanced business degree, and really licensed to be dangerous in a number of areas and not really an expert in any one of those, just smart enough to ask dumb questions and make my engineers laugh at me. And I describe myself like a child who just doesn't know the boundaries of what cannot be done, and so it kind of works. I'll surround myself with a bunch of smarter folks, and away we go.
Wait, thank you so much, and each one of you for being here. I'm pretty sure this is going to be great. And why don't we start with our first topic, that is design and development of robots. We'll start with Denis. Can you share a specific example of how AI has enabled a breakthrough or significant improvement in your industry?
Sure. So as I mentioned in introduction, Sarcos is really specialized in the unstructured environment. So unstructured environment for robotics is really an environment that continuously changes. Every time you bring the robot, you see different scene, you see different objects. You operate in an outdoor environment. So those situations are very difficult for AI or for perception, because in industrial robotics you kind of have a predefined environment, and it's fairly straightforward to pre-program robots to do this now. In our case, we have to basically perceive, we have to understand what we see in the scene and how the scene changes, and then intelligently control to execute those tasks. So AI is really perceived as kind of closed loop system in which you can sense internally what's happening with the robot, but also externally with cameras, with lidars, radars, identify those objects or things that you need to manipulate, and then actually close the loop with intelligence that AI would provide to manipulate and finish the task. So that's kind of a little bit different than perhaps in some other applications, but we use this sort of online version of machine learning or AI that has to run on very constrained computational hardware. So we don't have a huge computers to run those things. They have to live on a robot itself. Robot is constrained with the weight. So there's a lot of challenges that that kind of environment poses. And then building sort of capabilities to execute different tasks is another kind of component where AI comes into place. How do you decide when to use specific tasks, and when do you actually use specific tools to accomplish those? So there's a lot of challenges on multiple fronts, but we use also human intelligence to guide in some aspects or teach the system how to behave, and then actually replicate or learn the behavior and then execute in different situations.
Okay. Well, thank you for sharing. And now that we have your perspective on robotics, Brandon, can you share a little bit what are your thoughts on this in your specific industry?
Oh, certainly. So great answer initially, and good lead into aerospace. So think building airplanes and fixing them, two aspects of aerospace. On the building side, it's really exciting because now we can, feed the AI algorithms a giant amount of data, potentially say for computational fluid dynamics. So fancy word for put part in the computer, model the aerodynamic flows around it, and we tell the computer what kind of outcome we want. We want minimum drag, we want maximum amount of lift from the wing. And now we let the computer, within a certain parameterized set of limits, change the topology of that part. And now it's looking for those changes which yield a positive. Based on all of its data that it's learned, it can most likely start here and change a couple of parameters. And now we have a dramatically more optimized part right away. And that sort of optimization also applies to structural engineering. So, making the part stronger and lighter, topology optimization is what it's called. So a lot of exciting on the stuff on the building side. On the fixing side, it's called maintenance, repair, and overhaul. Now the major companies, Boeing, Airbus, they have a huge amount of data from years and years and years of engines breaking and different parts on their aircraft breaking. Now we can have a computer comb through it from an AI perspective and take a look at patterns that would never be recognizable for a human being, but now computers can pick it up, identify patterns, and now optimize and use predictive algorithms to then look forward to parts that might fail at a certain time and design maybe an inspection cycle that would look at that part and do predictive maintenance instead of catastrophic, failure maintenance, where you break something in. So a good example of this is Delta Airlines. I think it reported in 2019 they saved $40 million using an AI predictive algorithm to get ahead of some of their maintenance. So pretty exciting on both the build side again and then the fix it side in the aerospace community.
Well, thank you for sharing. Yeah, I did read about the Delta news. So thank you for sharing that as well. I think it's really interesting what happened and what is going to happen as well. Now, Venki, this one goes for you. What is your opinion? I think this one is really interesting because it talks on the cultural side. What do you say is your opinion on the differing attitudes towards robotics between the Western world, which views robots as potentially dangerous, and Asia, which sees them as beneficial?
I mean, I don't know whether I would put it as the two worlds are different. But I think it's a fairly valid question, right? Robotics and AI has been considered as, great innovations for productivity. There are a variety of things, right, where the robotics and AI are going to come into use, whether we like it or not. I think it is in there. We are going to be there, right? That's your, the Asian view that you, put. I think it's not, I wouldn't say it's just Asia. I think it's all over the world. Robotics and AI as an industry, it is going to change. There are several things that we do, right? That's a good thing. What you frame as a Western world is, should it be unstructured and should it be totally chaotic or not? I think that's a valid concern, especially AI as it takes off. It's going to get more and more critical. I think the way that I look at it is, especially from an AI side, right? At what level of decisions that AI makes, right? I think, do we want to set some boundaries? Can it make autonomous decisions? And if so, what are the decisions it makes? And how do we make sure those decisions are valid, right? I think that's kind of where the Western world, as you put it, differs. But I think it is still a generic concern across the world. And I would agree, but with both the main perspective, and they are valid problems, and we are in a growth from robotics and AI perspective, and it's just going to continue, and it will be in a way better place in the next few years.
Oh, thank you for sharing. Denis, do you have anything to share regarding this point?
Well, we often face, sometimes robots can look intimidated too. Especially when we're building manipulators too, and then putting kind of intelligence in those. So we have a line of exoskeletons, and in some cases that itself could be intimidating. But combining of the design principles, like similar to Apple design, you can smooth those kind of differences and introduce them into environment in which they really enable human to be aided and reduce injuries of the workers and so on. So there are aspects of I think introduction of kind of robotics and AI kind could be perceived as intruding. But there's also a way to kind of smooth that transition by saying it's enabling, actually still keeping the human in the loop, but taking the human out of harm way. And I think if you kind of look that way, I think both, again, I don't necessarily agree West and East culture, but both cultures want to keep people safe and reduce injuries, which increases productivity. So I think if you can see the world that way, I think becomes more beneficial rather than looking for the malicious things in AI or robotics, right?
Yeah, that's true. Thank you for sharing. Great perspective. I think the origin of this question is from what we see in movies. I think it all depends on, changing the mind of the people and the culture. And, it's a slow transition, but we're getting there. So I think it's really interesting to hear both perspectives, especially from you guys being on top of it. So thank you for sharing that as well. And now we'll go to Brandon. I would like to ask you, what are some of the key considerations that designers and developers need to keep in mind when integrating AI into any robotic system?
Great question, Elisa. I think first, safety. I mean, everything has to be formed around safety. The minute robots starting, especially ones with AI on board, start hurting folks, or there's the safety is not carefully considered, I think that's going to start to ring alarm bells, and a bunch of cascading negative effects kind of go from there. So I think safety is a great umbrella under which to develop almost all of the other sort of pieces. Of course, functionality is a piece of that, but so I think that's one key consideration. I think maybe underestimated in the weeds of making this all work is data management, right? So AI has to be fed a lot of data. And so now we're seeing it, in the real world, who has access to what database to train the AI. People are being very protective of their databases, rightly so. They built up over time, Reddit, some of these other places. And so a smart data procurement and management plan within the company or any AI endeavor, especially on the robotic side, is pretty important to consideration. Of course, everything needs to be integrated and communicated. That's kind of a no-brainer. And I think finally, again, linked to my first safety, anything that interacts directly with humans, so has the ability to physically harm or interacts directly with humans, has to be given very special consideration, especially when there's AI on board that has some sort of, for lack of a better word, some black box autonomy, where we don't know exactly how it's doing what it's doing in terms of where it's going cognitively, but it is going to come up with some sort of output, and we want to make sure that does not physically harm sort of anyone. So I think there's a number of different considerations. This is probably a very long discussion, but those are kind of my off the cuff sort of thoughts.
Yeah, that's true. That determining the right data set, data security, storage, all of that, I think that's key as well, just like you mentioned, and safetyness. Venki, can you share a little bit about it?
I mean, my answers are so similar to Brandon's in a way, right? I mean, I think the way that I look at it is robotics, leave AI aside, right? If you look at robotics, it existed for decades, right? I mean, it is not anything new. Industrial automation has existed for, several decades. And that there are some variety of factors to be considered, and they are still valid, right? But where we are in the field of robotics and AI is a newer paradigm where these two are mixing with the humans and going to start working as a human assistance, right? So I think we are at that phase today. Let it be, the airplanes are, with the blended kiosk, it's going to be working with the humans, and safety in this world is probably the topmost thing to be watchful for, right? From a developer or whoever is building the system. And besides safety, and especially when it comes to AI, because it's making these black box decisions, how do you actually test it? It becomes a very critical problem, right? There is a lot of data. And just imagine an autonomous car going through streets. How do you make sure that the robot is not going to make a wrong decision, right? I think that's a fundamentally critical problem. And then the designers should put special attention to the data sets and how they mine it, and what is the test set and how do you test it, right? This is fundamentally critical. And the other one that has to be watchful for is how do you debug, right? Because these are black box systems now, right? So they are making decisions to assist humans, how do you, if things go wrong, how do you even debug, and how do you figure out, okay, what went wrong, right? Because it's not someone writing a specific line of code, right? It is making a decision. In our case, for example, it is deciding whether there is a cup is placed on the counter or not, right? Sometimes it makes mistakes, right? I mean, how do you debug when it makes a mistake? What makes it, create a mistake? And these are fundamental problems that we are going to embed into, especially when robot and humans are going to intermix, and it's going to evolve. So, obviously, safety is the number one, and then make sure that how do you test and validate is fundamentally critical.
Well, thank you. Great answer. Thank you for sharing that as well. And now that we're talking about safety net, Denis, what do you say are the main challenges that Starcos, or you especially, have faced when it comes to this integration, especially now that you're building exoskeletons? I think that's super interesting.
Well, it goes back to, safety is a really critical part. You cannot deploy any of your products. Exoskeleton is critical for safety because you have a human in there, and you have to interpret the intent of that human, and allow them to work as exoskeleton is not around them, but also prevent of tripping, falling, and all those issues that. So that's that's a machine that actually have a human inside, and it's very, safety is absolutely critical, and not only software safety but also mechanical safety. And if you kind of integrate software that has capabilities of AI, which we do, to estimate intent of the user, that also has to be tested and vetted. The application that we also dealing recently is also solar panel installation, like autonomous solar panel installation. You still have workers. You're replacing quite a bit workers that install the panels, but you still have a few in there. And if you manipulate a solar panel that weighs 100 pounds with reach of a few meters, and then worker is under that solar panel, your perception, your recognition algorithms had to function perfectly in solar flare or rain or any of those conditions. So safety becomes really the utmost important factor. You cannot really deploy that product unless you can show the customer that it's safe to operate and safe to use. So combination of hardware, software, all the intelligence that you're trying to put in there has to be tested, validated, rigorously. But that takes time, which kind of is a trade-off. Release the product, or make sure that you checked all the safety issues that you will run into it. So that's a really big sort of task for engineering teams to guarantee that sort of safety. Data is another aspect. Every time we operate a robot, we getting the data. Data is part of the system. Procuring the data, receiving and then monetizing. That's another aspect that we are also focusing.
Yeah, that's true. Well, thank you for sharing. I think we all rely on safety, and it's needed in order to deploy our actual product. So thank you for sharing that as well. And now jumping into our next topic, that is human-robot interaction. Venki, I would like to ask you, how do you envision the future of human-robot collaboration, and how is Blended shaping that vision?
It's an interesting, I would kind of answer it from a blended perspective, and then I think others can share. When we look at from a blended perspective, there are two major aspects of human to robot interaction, right? So one is our final customer, right? The ultimate customer who walks into the kiosk, orders a drink, and then gets the drink. And then here, the robot needs to mingle, and the human should be able to talk to and then work. Today, our systems are built where it's a phone, and then you take your app to download and then place the order, and it's going to evolve into a humans naturally walking in and then talking to the kiosk and ordering the drink. I think that is one aspect of human to robot interaction that we have been playing with. The second aspect of human to robot from a customer perspective is people like recipes, right? So we have a lot of chef created recipes, We want to, the AI can generate recipes that customer likes, right? I mean, I want to stay healthy. I want to stay within my bounds. And then based on the ingredients, it can suggest brand new recipes. This is another big area of human to AI interaction that we play with. Right? The second big bucket is operators, right? The operators in our world are the folks who actually service the kiosk, right? They're going to interact with the kiosk and move things around and so on. So that is more the traditional safety aspects of kiosk, right? We use a cobot. It is designed not to hurt people, but still when the robot moves, people get scared, right? I mean, even if it moves really slowly, right? And how do you make those gestures and movements such that it is more human-like and, I mean, interact with it? That's fundamentally critical. That's kind of, these are the areas that we work with from a human to robot interaction perspective.
Yeah, thank you for sharing. And that leads me to my second question on this topic. Brandon, how do you think we can teach robots, just like Venki was saying, to collaborate with humans, but in a more natural way?
Well, that's an interesting question. It's not easy, to be honest. I think teaching robots, again, I'll answer the question from the perspective of robots with black box sort of AI on board. Large language model might be the easiest. So a robot with ChatGPT that wants to interact with a human. So Sam Altman, I listened to a really interesting podcast with him and Sam Harris, or I think it was Lex Friedman, actually, disregard Lex Friedman. And he was talking about actually just making the robot and the, in this case, ChatGPT, more friendly and less annoying is one of them, right? So I mean, people just do not want to be told what to do by a robot. Even I don't like to be told what to do from anybody, let alone a little machine that I'm supposed to control and it's supposed to work, for better or for worse, work for me, right? And so he spent a lot of time on the podcast, and it was quite an interesting point. And they spend a large amount of time making sure that the AI communicates with the humans in a very socially acceptable manner. Funny enough, I thought it was an interesting point, and I had not considered that. And so I think that's one aspect of, more naturally communicating. I think another aspect, there's an actual thing, it's called the uncanny valley, right? If the robots, and now with AI on board, look sort of like humans, really like humans, but kind of not quite in a really weird way, it can go sideways from a human acceptance perspective. So, yeah, and I think the third is just opening humans' minds in terms of what these robots can do, the level to which they can improve their daily function in their job or in their lives, or even in even medical and material science, all sorts of things. I think there's a lot of different ways that we can collaborate. So, I mean, teaching robots to teach humans the different ways in which they can help them is another sort of way of doing it. If you kind of read me.
Yeah, that's true. Thank you for sharing that as well.
Yep.
And now that we talk about human-robot collaboration, integration, how AI relates to robotics and in one of your industries, I would like to jump into the next topic, and that is regarding the influence of AI on productivity and economic growth. So let's jump into that. And Denis, this is for you. As CTO, how do you manage or navigate the expectations and hype surrounding AI influence in the hardware sector?
Yeah, so maybe I can a little bit answer previous your question that leads into hardware. So it's kind of unique for Sarcos because we don't want to necessarily just let AI learn all the behaviors of it, but we also want to use human intelligence reflected through motion to capture that behavior and then learn with a few demonstrations of how a human would do it. Then we can actually deploy the algorithm that will capture that behavior and then repeat in other situations. So that kind of transfer you into the hardware component. Because I mentioned earlier, we are really focused on unstructured environment that always changes. If you install solar panels, each field is different. Each field has a different elevation, inclination, and each tube which you install is different. So we have to be able to kind of almost react or predictively act with the controls and perception to accommodate for these different situations. So AI is traditionally kind of done, let's train on the huge quantity of data, put it in the use, and let's kind of create that sort of either recipe or create ways how we move around. But in our case, we have to really act as we proceed in all these tasks. So in our hardware task, for example, the installation of solar panel, robotics is used there to improve productivity, but also to improve flexibility of the worker. So worker can teach machine that provides flexibility. So you don't have to be hiring expensive programmers to do the work. Teaching machine can be done by the worker, but then increases also productivity because then worker steps out and machine takes over with some of the oversight. The same applies in our underwater applications in which we have to repair a cable with two dexterous arms attached to the underwater vehicle. In this case, again, everything underwater will be perhaps seen for the first time, right? So you can actually, humans are very good in acting or adapting to new situations. So if we can actually have human teleoperate that robot initially, then we can have AI algorithms to learn that behavior, and then we can repeat or replicate on different situations, or on the same situation that will take the human kind of out of repetitive task, but still use that intelligence of humans to be captured in AI. So that's kind of transitioning from sort of human interaction to capturing in intelligent algorithms of software, and then moving into applications that will actually enable human to do less repetitive work, take them out of the harm bay, but still have them sort of interface and interact with machine.
Wow, thank you for sharing that perspective. I think it's great. Yeah, the influence of AI on productivity. Talking on the worker side, it's interesting. And now let's jump to Venki. I would like to ask you, how do you address the ethical concerns surrounding AI integrated robots, given their potential to accelerate job displacement while still fostering overall economic growth and maintaining a positive impact on the society?
I mean, this is going to be a question that is going to get asked for several years. I mean, I think this is true with any revolution that takes place. We have gone through industrial revolution, we have gone through computers, we have gone through internet. So with any of these technologies and revolutions, there's ethical concerns of, hey, is it going to take away my job? This has always existed, and that's going to continue to exist. But my personal view is it really doesn't displace jobs. Yes, there might be a smaller impact in certain sectors. Take our sector, Blended, as an example, right? It's a robot that makes smoothies, right? It doesn't, if you look at the food industry right now, especially after pandemic, the industry is finding it difficult to even hire workers to do food service environment. It's actually not replacing jobs at all. They are just finding it harder, right? So our demand is growing because people are migrating away to better paying things, right? So the robots take over tasks that humans don't want to do, in fact, right? So that makes it easier, right? So it is not an ethical concern of job displacement. It is more about job migration, where we are shifting, a lot of jobs from one type of job to a different type of job. That's what is going to take place. Obviously there will always be a noise in the industry in terms of job displacement, but in my personal view is it's going to make the humanity, all of us will be more productive. We are going to be much better, right? So that's my take.
Thank you for sharing. Brandon, do you want to share anything on this?
Yeah, certainly. I could not agree any more than that's just perfectly stated. So I actually take the counterintuitive sort of place that I think robotic, the advancement of robotics and AI will actually create more jobs. It won't take away jobs. In the grand scheme of things, if you draw the dotted line around the larger system, I think exactly what Venki said, there's going to be more jobs for human beings. They're going to be higher quality, more interesting. Instead of humans sitting on an assembly line and putting stuff together repetitively, we're going to be building the machines that build the cool machine. And it's, there's a lot more high-tech and interesting work there than there is just putting bolt number 5 into hole number 7, repetitively for 8 hours a day. So that it's just extremely well said.
Thank you for sharing. Denis, do you have any to add?
Yeah, I like this this analogy of job migration. The perfect example is just really the solar field. We're not replacing the people, but we actually are teaching them to use different skills which are much higher paid jobs and also more interesting skills. Instead of lifting panels and installing and repeating the stuff, you're doing something more advanced. You're wearing perhaps VR goggles and you teleoperate this robot, which I think is much cooler than lifting this in 110 degrees Fahrenheit in the desert. So yeah, I think it's just a job migration, adaptation of workforce to higher level skills, better job pay, and this sort of fear that somehow we're gonna be replaced by AI and robots. It's probably unfounded, but as Venki said, that every new revolution comes with a fear, and change is a kind of it's not easy for people to make changes, right? But I think we are on a good path to be more productive and more flexible.
That's it. It's all a transition. Thank you for sharing that as well. And now jumping into our last topic, emerging industry trends, I would like to ask you, Brandon, as AI continues to advance, what aspects of robotics excite you the most, and what potential breakthroughs are you eager to see in the near future?
Can I say everything? Literally everything about it? It's very, so from an aerospace perspective, I mean, now you have AI algorithms fed tons of data, producing new potential material sciences, all the way from, well, I guess this gets into, quantum computing and whatnot, but, room temperature superconductors, different crystal lattices, nuclear fusion control, where a human being just could not capture the data, analyze the patterns, and then come up with a predictive algorithm to control the fusion. We're seeing tokamak fusion reaction and eddy destruction by very complex AI-based sort of learning systems. I mean, it literally everywhere I turn, there's just a lot of optimism from my perspective, and a lot of cool things that it can do. So, I mean, I'm speaking a little bit outside my expertise in the aerospace community, but again, even in the aerospace community, if you're worried about more efficient future travel, more sustainable way, again, better ways to build airplanes, more efficient ways to fly them, this is a long topic, but it's ton of optimistic potential out there.
Great to hear the aerospace perspective. Thank you for sharing that as well, Brandon. And Venki, from the robotics perspective, anything that you're excited about?
Yeah, I mean, like Brandon said, I can't say everything. So, but to just think about it, there are few areas that really excites me more, right? Robotic human interaction, the safety aspects to it. Yes, it is a challenge in terms of how these two are going to work together and make better recipes or better food. It's going to be fun to watch, right? I mean, as humans, we are all very picky about what we eat, right? We have our own tastes and preferences and whatnot. And the combination of these two to make these delicious things that you love is what I mean, one area of what I look forward to. There's the second area, which is kind of new because, I mean, especially after ChatGPT and then LLM models, right? So, I mean, it is interesting and fascinating to see how the natural speech is evolving. And in fact, we dabble with it quite a bit right now at work, from either answering customer questions and how do we put it to work, to how do we write code, right? So we are going to be in this area where the AI is going to be an assistant to humans, and that's going to increase the productivity of what we do, right? Every software engineer is going to be 10 times more efficient, and the same thing would apply to a hardware engineer. So our productivity is going to go through a roof, right? I mean, yes, there might be a short-term impact, but overall, we will get a lot more done in the near future than what we've accomplished in the past. So that's really going to be exciting 10 years ahead.
Glad to hear that. Thank you. Thank you, Venki, for sharing. And well, we have a couple of minutes left, and I would like to continue with a couple of questions from our audience. And the first one will go to you, Denis. What do you think is the most common misconception about AI and robotics that you would like to address?
There's a tendency to say, well, AI should be just doing everything, right? And when I talk about AI, it's really more, perhaps a little bit different than Brandon's or blended approach. But we, as in this field, we have to be able to adapt in a kind of online fashion to things that are changing continuously. And those capabilities of sort of AIs are perhaps not there yet. We are very good in recognizing things. We are very good in kind of design choices. We are very good in interpreting speech because it has sort of those identified patterns that you can repeat and repeat over. But how do we actually capture this sort of way how human reasons and project that reasoning back into the motion and also execution of complex tasks? So right now, robotics is very sort of driven by this, kind of pre-program the sequence, but then how do you change and adapt to changing situation? And can AI actually be at that level of sort of reasoning that perhaps humans take for granted very quickly? So we are trying to kind of capture those components of human reasoning, human kind of memory recognition, association between like what you knew about before and what you see currently, and then can you actually apply those learned skills to a new situation, and then also learn those skills that you just executed on that task and apply to something else. So there's a lot of, I think there's a lot of long way to go before we can get fully intelligent robotic system from perspective of manipulation. Perhaps aerospace is very also similar to that. Manipulation is essence, but dexterity that I'm talking about is also a component of our robotic system. And then kind of this end effector, which is your hand by itself is so intelligent. So how do we actually capture that in either new hardware, but also enable that by the algorithms or software that comes perhaps from AI? So AI definitely has different kind of fields and different flavors. So I think there's a lot of focus perhaps now on the let's kind of interpret the speech, let's kind of capture the text. But there are so many other challenges in simply manipulation that AI is not there yet, and perhaps will require more focus there.
Well, thank you for sharing. Interesting perspective. And I would love to hear your perspective on this, Brandon, from the aerospace industry.
And so the question is, common misconceptions about AI. I think from the aerospace industry, again, it's Denis was very well said. Its applicability is broadly overstated, so it's very good. I mean, we still only have narrow AI systems. Let's be honest, we're very far away by most researchers' opinions from generalized AI. So we have narrow AI. It's very good at doing very specific things. But I mean, there's a lot of catchphrases that get thrown around, right? Sustainable quantum AI computer, or you know what I mean? It's just a lot of sort of catchphrases. You have to be careful about what you aim the AI gun at. And it has to be an economically sort of feasible action and with a realistic probability of getting something useful out of it. So in aerospace, for example, again, I give some examples of real world awesome things where we can make parts more optimized, stronger, lighter, more aerodynamically shaped. Those are really good narrow applications. You're not going to install a brain in a computer anytime soon that is going to make all the proper decisions and fly the aircraft autonomously to its destination. That we're still quite a long ways off there.
Thank you. It is a transition indeed.
Yeah.
And Venki, last but not least, this question is about how might the advancement of AI-powered language models, just like you mentioned, like ChatGPT, impact various industries such as customer service, healthcare, or education?
I mean, it's already impacting heavily, right? I mean, I think I'm pretty sure we all have played with the ChatGPT and love the power of what it's able to produce, right? So you had the Google world, and then there's a regular chatbots world, and then now we see the power of AI in terms of, how ChatGPT works. But especially, as I mentioned earlier, right, ChatGPT alone, we typically look at it as it is answering questions from a customer service perspective, but it can be used in many different things. And as I mentioned, right, it writes code for us, right? We can feed it code and it optimizes the code for us. And the engineers have a problem, we can feed the code and then tell them, hey, here is a problem, and it debugs it for them, right? It's just phenomenal in terms of even in the software world, how much the ChatGPT as an AI can do, right? Same thing with making presentations. It's good. It has the power to help human beings to be so much more productive across a wide variety of industries, right? And I couldn't be more excited.
Well, thank you for sharing. Denis, anything to add?
we're still trying to figure out what's the best way of using this. I mean, obviously through kind of interpreting commands of people in a noisy environment is a good example. That possible that you can transcribe what somebody, instead of yelling and screaming for somebody to hear you, you could transcribe that very quickly, including different languages. And but also, I think from my perspective, I'm more interested, and we've been working on this, some of those aspects before even GPT. How do we actually transcribe the tasks that's expert, let's say, mechanic would do naturally? How do you now break this down into the sort of tasking for the robot and do perhaps this through natural language interpretation? Can that mechanic actually express himself in those how he perceives solving the problem, and that kind of transfers back into the sort of tasking of the robot to execute those commands. So you can actually teach the robot not only through physical motion, but actually through sort of interpretation of language or your expertise, perhaps. So that's again kind of more cycles driven, but there's obviously many uses of that. I would kind of say that actually people start using more and more for writing, expressing their own sort of creative writing tasks, and I think that could be a little bit just kind of a little bit freaky to me. Like, I think I was reading a New Yorker article in which people couldn't recognize which article was written by expert journalists versus so that kind of reduces our creativity, but maybe there's a chance of also improving creativity by kind of almost being an editor for that article. So yeah, there's definitely a lot of opportunities.
Well, thank you for sharing your perspective. And well, I'm going to take the opportunity to close and wrap this panel discussion and thank each one of you for coming today and talk about the role of AI in the future of robotics. Are there any final comments, anything you guys want to share before we close up? Oh, yeah, go ahead, Brandon.
I just wanted to say thank you, Elisa. It's been a fantastic panel. Feel very privileged to be on it with such smart folks. So thank you.
Oh, thank you. Thank you for coming as well.
Same thing. Yeah. Thanks, Elisa, for setting this up. Nice meeting you, Brandon and Dennis. I mean, I think it's just, I learned more from you guys as well as, sharing, whatever I know as part of this panel. Thanks for setting this up, Elisa.
Well, the same. Thank you very much. This is very interesting because there are three different companies, right? But we kind of talking about the same things and different applications. So definitely a lot of learning opportunities.
Well, thank you so much. It was great hearing your experiences and insights on the topic. I want to also thank the Builder Nation community for being here today, and we'll make sure to follow up with resources and links in case you missed it live. And remember that you can also find more information, interesting articles, interesting interviews directly on our website, controlhub.com/builder-nation. We would love to hear from you. And once again, guys, thank you so much for joining this panel.
Thank you.
Thank you.
Have a good day. Bye.
Yeah, bye.
When building the future is your priority, tedious procurement processes should be last on your list. The problem is that purchasing data is scattered across spreadsheets, receipts, emails, and messages. Tracking it all sucks and makes it easy to commit mistakes. Introducing the Control Hub Way, the all-in-one purchasing software for hardware companies. Buying parts, services, or office supplies? Submit a quick purchase request to buy from your list of approved vendors, or buy from a new provider. Buying from approved vendors is even easier. Import your shopping cart directly into your purchase request using our checkout. Ready, submit it for approval. We'll ping all pre-designated approvers both via Control Hub's website, email, and Slack notifications for a faster turnaround. If you need a PO, we got you. Generate it in one click. Online purchase? Boom, virtual card. Do an automatic 3-way match, pay invoices, and sync everything live with QuickBooks or NetSuite. Purchasing just got a lot easier. Control Hub. Get back to building. This panel was brought to you by Control Hub, the purchasing software for hardware companies.